Okay, thank you for being here. Thanks for staying. As someone leaves. All right. Okay, I'm Maury Gaston. I'm with American Cast Iron Pipe out of Birmingham, Alabama. We're going to speak today about supporting the heart of the water, energy, food nexus. Now, as you well know, a nexus is an intersection of two different things, two different groups, two different functions, what have you. This is a little bit about myself. In the interest of time, I'll be pretty quick here. I'm in sales and marketing. I've spent my entire 42-year career with this company in sales and marketing. We hire engineers for sales because we manufacture technical products. We call on technical customers and clients, and we feel like those with a technical background are best able to provide service and respond to those clients and customers. So that's why you see a mechanical engineer running the marketing department for this particular manufacturing company. I vice chair the American Waterworks Association Standards Committee that governs ductile iron pipe standards. That's pipe, joints, linings, coatings, fittings, flanges, installation, those sort of things. I speak at a lot of conferences. This is my second energy environmental utility conference. I actually gave this presentation 7 years ago, and the version that you have in paper is from that conference. I've updated my slides since then. I chair the Alabama Iron and Steel Council. That's part of Manufacture Alabama. Alabama is the nation's 5th largest producer of iron and steel. And most people who are not members of the Alabama Iron and Steel Council would know that. We've got tremendous iron pipe industry in Birmingham. We've got automobile plants scattered throughout the state. Nucor produces coil steel in 2 locations in our state. It's manufacturing in the state of Alabama is booming. It's a great place to be at this particular time. I'm a director and a past chair of the State of Alabama Engineering Hall of Fame and my university engineering council. So water and energy. Water was probably the earliest, certainly an early source of mechanical power. On the left, you see a water wheel. Gravity flow of water turned that wheel, which drove a shaft in a factory, which operated the machinery. On the right, I'm going to guess, although I probably should know, that shaft in the ceiling is probably powered by a steam engine. But even at that point, the steam comes from the water. So water was if not the original, very early source of energy for manufacturing and other purposes. Let's look at water use in the United States. Per capita use of water is down 38% since 1950. That's pretty remarkable, I think. There are efficiencies in every use of water across the country. Power generation, home consumption, irrigation, farming, residential home, lawn irrigation, so many things. You see each of those bars trending down for the most part. The largest use of water is electric generation. 45% of the United States water use is for electrical power generation. The green bar is irrigation, and that's the second largest use right here. I've got a slide next that talks about how much acreage across the country is irrigated. And then the purple bar here is public supply, and that's where your home residential water comes into play. A typical home with 4 residents would use about 10,000 gallons of water a month. It takes 25,000 gallons of water a month to produce the electricity that home consumes. So 2.5 times the water that the family uses to live in their home is used to provide the electricity that home consumes. Now, I've been using the word use. I have not used the word consumption. We don't consume water. We use it, and it returns to the water cycle. And that's a very important thing to remember. We've got all the water we've ever had. and we've got all the water we're ever going to have. And I'll show a slide later and speak about a topic that kind of addresses that. Our problems today with water is that we've got water in one spot and we need water in the other spot. We get 60 inches of rain every year in Birmingham, Alabama, where I live. 60, 5 feet. That's right here. And it all flows into the Gulf of Mexico. We had these torrential rains in California last week, and it all went down the concrete Los Angeles River into the Pacific Ocean. I drove here this week from Birmingham, and every creek and river I crossed in Mississippi was out of its banks. We're letting all this water get away from us. And I've done another paper and other presentations at other conferences. I'd love to do it here. We could build an interstate pipeline network. And we could put a 12-foot diameter straw in the Missouri River at Leavenworth, Kansas, and we could pump it west to Iowa and Nebraska and inject it into the Olagala Aquifer, which has fallen 1 to 2 feet a year, and recharge that groundwater. We could build a network of pipelines to Lake Mead and Lake Powell, and it would take years, but we could fill those lakes up again. And then when these floods come and so forth, turn the pumps on and let's move that water to where we need it. This is a percentage of acreage in each state that's irrigated for agriculture. Now, 8% of Texas acreage is a lot more than 15% of Nebraska acreage. And 14% of California acreage might equal half of that whole pie chart, I don't know. But lots of water goes into irrigation. And you'll see here on this slide how many gallons of water it takes to produce 1 pound of beef, 1 gallon of milk, 1 gallon of wine, 1 gallon of beer. 1,800 gallons are used to produce a pound of beef. And you think, golly, I didn't know cows drank that much water. Well, they eat grass and they eat hay that grew by consuming water, by using water, excuse me. So those are fascinating statistics, I think. But remember, we're using the water, we're not consuming it. We'll get it back. So here's the top of page 1 of my paper about building trans-basin pipelines as a solution to our water resources. You know, they didn't think we could build a railroad across the Rocky Mountains, but we did. We connected the East Coast and the West Coast. We connected agriculture in the West to demand in the East, livestock in the West to demand in the East. And the Transcontinental Railroad totally revitalized and energized the American economy. We've got an electrical grid across the country where a hydroelectric dam in Alabama can burn a light bulb in Minnesota. We've got natural gas pipelines that are thousands of miles long to move gas from where it is to where it's consumed. Why not do the same with water? Well, there are a couple of reasons, and I address all these objections in that paper. Water's heavy. It's 8.5 pounds per gallon. And you'd have to pump it up a real high hill to get it to the other side. It's also cheap right now. And until people change their mindset about the value of water, we're probably not going to get the funding to do something like that for it. You can build a 12-foot diameter pipeline for less than you can build an interstate highway. And yet we've got interstate highways from coast to coast. And there was opposition to the interstate highway idea because a lot of states didn't want other people to have access to their markets through the interstate highway. President Eisenhower got funding for the interstate highway system as a military initiative to move people and material across the country to prepare ourselves against attack. And it's taken 7 decades to get the interstate highway system to where it is now. My dad often said the best time to plant a tree is 25 years ago. And the second best time is today. So every chance I get to talk about building an interstate highway system to move water from where we have it to where we need it. I take advantage of that. Now let's talk about the company that makes all these products that supports the water, energy, food nexus. I'm proud to work for a manufacturing company, a company that makes something that you can put your hands on, that takes a raw material and transforms it into a useful product. I'm also proud to work for a company that makes a product that serves essential parts of our economy and contributes to public health, like ductile iron pipe, valves and fire hydrants, and spiral welded steel pipe. The man on the left was our founder. He had a dream to invest his money in what he called a noble purpose. The lady on the right is Charlotte Blair. She and her brother James Blair knew that Birmingham, Alabama was an excellent place to build a cast iron pipe factory because we had iron ore, limestone, and coal, all within a 30-mile radius. So the cast iron pipe industry grew up in Birmingham, Alabama at the beginning of the 20th century. Our company was founded in 1905. And there two other iron pipe producers had facilities in Birmingham. Now this is our plant. It's 2,000 acres. It's 3 miles from east to west. We employ about 1,600 people here. When I started 42 years ago, we employed 3,500 people here. We didn't lay anybody off. It was all attrition and retirement. But we have done efficiencies and modernizations and all the things that y'all talked about in your other presentations, so that our employment today is 40% what it was 40 years ago, and our production is 6 times the tonnage that it was then. And we were sustainable before sustainability was a thing. Our raw material is scrap iron and steel. The product we make lasts longer than other products. The typical life of an iron pipeline is 100 years. Iron pipe has a larger inside diameter than the same nominal size diameter made of another material. The inside of 12-inch iron pipe is bigger than the inside of 12-inch plastic pipe. That's a whole other topic. So it takes less energy to deliver the same volume of water through an iron pipe than it does a plastic pipe. So those 100 years that you're using our product, you're consuming less energy. It's not unlike getting 20 miles a gallon with one car versus 15 for another. Pretty soon, you're going to cross that tipping point of the higher initial cost of the 20 mile a gallon car and the higher initial cost of the ductile iron pipe. And then if you ever take iron pipe out of service, guess what? You can melt it and make a new pipeline. All right, I want you to notice this parking lot. It's full of cars and trucks. We didn't ask everybody to drive out here on a Sunday afternoon so we could take a picture. The plant is in production. They're making pipe when this picture's taken. Here's a stack. Here's a stack. You don't see any dirt coming out of it. This is a clean manufacturing process. Our 2,000 acres, we don't discharge a drop of water off our product. We recycle all of it. What evaporates and has to be replaced, we get from the Birmingham Industrial Water Works Board. We've got 4 settling ponds. It's a clean manufacturing operation. Now, right here, a lot of railroad tracks. That's very significant. Every one of these red dots is a depot, a logistics center, a stockyard. We ship iron pipe to those red dots by rail from Birmingham. And we can do it across the entire country because we've got 4 railroad sidings at our facility. Whatever railroad serves Phoenix, it doesn't serve Massachusetts. It's like the airlines. You don't fly one leg on Delta and transfer it to American unless you want to go through all the security and bag check and all that stuff again. You can, but it's expensive and it takes a long time. Because we've got 4 railroad sidings at our plant in Birmingham, we can ship our product all across the country. economically. And we can compete with other iron pipe producers in Utah, California, and New Jersey, and Ohio. We got more pipe on the ground in those red dots than we do at our headquarters in Birmingham. And guess what? Rail is the most fuel efficient method of shipping a product. You can move a ton of freight 475 miles on 1 gallon of fuel. Now let's look at our products. This is ductile iron pipe loaded on a rail car to go to one of our stockyards. This is ductile iron pipe next to a trench in Hopkinsville, Kentucky, ready to be installed. Spiral welded steel pipe. You take a coil of steel about 6 feet wide, you trim the edges to make them clean and square, you twist it spirally, you weld it on the inside, you weld it on the outside, you put a cement mortar lining inside and polyurethane coating on the outside. 12-foot diameter. This is probably a 12-foot ceiling, I'm guessing. It might just be 10. 12-foot diameter. This is a parallel 10-foot diameter pipeline in Arkansas for the Corps of Engineers for a flood control project. Valves and fire hydrants. These are municipal fire hydrants, which you might see outside this building here. I've seen a couple already. The Darling brand is made in Texas. The Waters brand is made in Minnesota. We acquired Darling in '69. We acquired Waters in 1989. This is a resilient wedge gate valve. This is an industrial hydrant. This type of hydrant would be at a refinery, at a paper mill, at any industrial facility. It's got a fatter barrel. It takes higher pressure. You can attach accessories to it to direct the water and that sort of stuff. I included it in this presentation because that's the hydrant that would be used to support and protect the energy industry. This is a 36-inch diameter resilient wedge gate valve, and I'll show that to show the scope. We make these up to 66-inch diameter. A 66-inch diameter gate valve is 13 feet 9 inches tall because you got to have room up here in the bonnet to bring the gate up to open the valve. That's a smooth port opening here. It's got 1/10 the head loss of a butterfly valve, another energy efficiency. Another product for the water energy food nexus is our high frequency welded, electric resistance welded steel pipe for natural gas and for oil. That's made in Birmingham. We go up to 24-inch diameter. These projects are typically 200 to 800 miles in length. And what you see here is an ERW line being installed out west. They place it on these bunks, they weld the joints together, they wrap those joints for protection, and then a machine comes along and picks it up and lays it in the trench. It's remarkable how flexible a steel pipeline can be if it's long enough. This is a spiral welded steel pipe, 114-inch diameter in the Upper Peninsula of Michigan for a penstock. Penstocks are pipelines that flow downhill by gravity and turn a turbine at the bottom of the hill instead of turning a turbine at the base of the dam, which is up the hill. And we have an outfit in Pryor, Oklahoma, near Tulsa, called American Castings, and they make all the. I saw a presentation recently by the general manager of our plant. I learned so much. There are probably a dozen parts in this combine, is it? I don't know. That we make at American Castings in Oklahoma. John Deere, Caterpillar, all the agriculture and mining and heavy equipment manufacturers use castings that we make. So this is how we're supporting the food element of the water industry food nexus. And I will pause for questions.
you guys work directly with all the gas companies with taking the cast iron out? Like, do you help them?
Yeah, he's asking about cast iron pipe being replaced for the natural gas industry, and yes, we work with them some. In fact, I frequent a place in Birmingham for lunch from time to time. 6 months ago, I saw them taking out cast iron pipe that we had manufactured. Our very first customer was Atlanta Gas Light. We made the pipe in Birmingham, shipped it to Atlanta, and it was used for natural gas, not for water. So I was very interested in keeping up a fast pace. We came along in 1905. In 1905, people got their water from a well in their yard. And most people used an outhouse in their backyard. Well water, drinking water, and outhouses near each other don't mix well together. In 1905, thousands of people died every year from waterborne diseases. Typhoid, cholera, yellow fever, things like that. One of the Wright brothers died from typhoid 36 years before his brother did. All right, it was into that environment that Charlotte Blair had the idea of a cast iron pipe company to support the early proliferation of municipal water systems. And Mr. Egan, the man whose picture was on the left, knew that that was a noble purpose, because clean water is the greatest advancement in public health in the history of the world. Now, we've made a lot of advancements, but none surpass the advancement of clean water. And there are communities around the world today that still need clean water. And there are a lot of ministries and other things that meet that need by drilling wells and other things like that to relieve the burden on some of those family members to spend 2/3 of their day getting water for their family. So it sounds hokey to some people, but that motivates me, that I work for a manufacturing company that makes a product that has so much good and value. And I'm in the twilight of my career, and I just love talking about this and talking about the company. So, other questions, comments? All right, I gave you all a printed copy of the 7 or 8 year old version of this. My contact's on that paper. I got business cards up here, and too many words on that slide, but that's my contact.
Thank you.
Thank you. All right, let me see here.